Hello, in this video I'm going to solve the following problem for you. This is a problem on the topic of division algorithm. Let A, B, and C be odd natural numbers. Prove that the equation ax squared plus bx plus c equals 0 cannot have rational roots. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. For more problems of this type, the interested student can refer to the following playlist. The link to the PDF file that you see on the display right now is in the description below the video. Okay, let us solve the problem together now. So you know that if I want to find the roots of a quadratic polynomial, I, for example, can use ABC formula, which reads as follows: x equals to minus b plus or minus square root of b squared minus 4ac all over 2a. Of course, you know that b squared minus 4ac should be positive for the equation have real roots. Now the problem is telling that if a, b, and c are all odd numbers, it is not possible for this equation to have rational roots. So this means that what you see below the square root sign will not be a complete square if a, b, and c are odd numbers, yes? Because if b squared minus 4ac becomes a complete square, the square root of a complete square is a natural number. And then if you have a natural number here and these are also natural numbers, then the combination will be definitely a rational number. So in order to show that it is not possible for this equation to have a rational root, we need to prove that under the condition that a, b, and c are all odd numbers, b squared minus 4ac, the discriminant, cannot be a complete square. Okay, we will do it in two steps. Okay, I need to prove two statements first, even though they are simple, but let us just mention them here. So first thing is that let x be a natural number such that x squared is odd. Then x is odd. Okay, so we want to prove this one first. So proof. What do we say? We say that let us assume that this is not the case. Assume that this is not the case and x is even. So I'm using proof by contradiction. Okay, now that you agree that x is even, what can I conclude from this? I can conclude that there exists a natural number n such that x is equal to 2n. Therefore, x squared becomes 2n squared, which is 4n squared, but 4n squared can be viewed as 2 times 2n squared. But what type of number is this? This is also a natural number. So what I understand is that x squared is 2 times a natural number. So this means that x squared is, so thus x squared is even, not odd. And this is a contradiction, yes? So because you are telling me that x squared is odd. So if you don't agree that x is odd, then you have to agree that x squared is even in the contradiction with what you just said. Okay, so this is proven. The second thing that we want to prove is that let x be an odd natural number, then x squared is a multiple of 8 plus 1. Okay, so how can I prove that? That is also very simple. So let us look at the proof. Okay, when you say that x is an odd natural number, so I would say x is odd. From this, I can conclude that there exists an n in the set of natural numbers so that x is equal to 2n plus 1. So therefore, what can I say? X squared becomes 2n plus 1 squared, and this becomes 4. The first one squared, 2 times the first one times the second one, and then plus the second one squared. Between the first two terms, I can factor a 4n out. Then I will have 4n times n plus 1 plus 1. Okay, so far I have shown that x squared is a multiple of 4 plus 1, but I want to show that no, it is also a multiple of 8 plus 1. But this is easy because this combination is the product of two consecutive natural numbers n and n plus 1. If n is even, so it means that the product is automatically even. But if n is odd, then the next number is even, and then the product is again even. So in any case, regardless of what value n has, as far as of course n is a natural number, this product is even. When it is even, it is a multiple of 2 itself. So for example, I can say that this part is a multiple of 2, so I can write it as 2 times m. Yes, where m belongs to the set of natural numbers here. And then if I combine these two, 4 times 2m becomes 8m plus 1, and I am done. Why? Because x squared is a multiple of 8 plus 1, and that is exactly what I wanted to show. Okay? Okay, the last thing that I want to show is the following. If y is an odd natural number and it is not a multiple of 8 plus 1, not a multiple of 8 plus 1, then y is not a complete square. Again, I want to prove this using the proof by contradiction. Assume that this is not the case. And y is a complete square. Okay, what's the meaning of this? Y is a complete square yes, so from here I can conclude that there exists a natural number x such that y is equal to x squared. Okay, but now look, y is odd, x squared is equal to y, which is odd. So this means that x squared is itself an odd number. Okay, so y is equal to x squared, y is odd. So from these two, we can conclude that, of course, x squared is odd. But do you remember? In the previous page, we just showed that if x squared is odd, what can we conclude? We can conclude that x is odd. And again, in the previous page, we'll learn that if I have an odd natural number, then its square is a multiple of 8 plus 1. Yes, so this means that x squared is a multiple of 8 plus 1. But what does it mean? Y x squared is the same as y. When x squared is a multiple of 8 plus 1, it means y, which is equal to x squared, is a multiple of 8 plus 1. Okay, so what I can do, I can conclude from here that, okay, y is a multiple of 8 plus 1. Yes, but this is contradiction. Why? Because we have assumed that y is not a multiple of 8 plus 1. So then it means that we prove that. So remember, this is what we finally want to use to prove the problem. If I have an odd number that is not a multiple of 8 plus 1, then definitely that cannot be a complete square. Okay, now let us go to the problem. Okay, now we have this equation. A, B, and C are all odd numbers. We want to show that the root cannot be a rational number. As I explained at the beginning, I need to show that b squared minus 4ac cannot be a complete square. But what type of number is this? So b squared minus 4ac, so you know that according to the problem, b is odd, so b squared is also odd. By the way, I don't want to prove this. Proving these things are very simple, yes? So you can assume that b is an odd number and then square it, and you will see that it is easily shown that b squared is also odd. But because of the factor of 4, this number is even. And then what I'm doing, I am subtracting an odd and even number. I am subtracting an even number from an odd number. It is not hard to see again rigorously that this difference is odd. So this means that finally what I know that this number is odd. And I want to show that this is not a complete square. Okay, so the trick we learned. I know that this number is odd. My goal is to show that this number is not a complete square. So one way to do that is to show that this number is not a multiple of 8 plus 1, according to what we just showed. So now what I will do, I will tell you that, okay, so you told me b is odd. I proved that if b is odd, then there exists a p in n so that b squared is a multiple of 8 plus 1, yes? b is odd. And now you are saying that a is odd. So what I can say that there exists an n in n such that a is equal to 2n plus 1. And then you also say that c is odd. So this means that there exists, for example, m in n such that c is equal to 2m plus 1. Therefore, what happens for b squared minus 4ac? Instead of b squared, I put 8p plus 1 minus 4 times a, which is 2n plus 1, times c, which is 2m plus 1. And then I simplify this a little bit by expansion, yes? So it becomes 8p plus 1 minus 4. I will multiply these two pairs of brackets, so it becomes 4mn. Then I will have 2n, then I will have 2m, then I will have 1 times 1, which is 1. Okay, so let me open it up. So it becomes 8p plus 1 minus 16mn minus 8n minus 8m, and finally minus 4. Now what I will do, between this, and that, I factor an 8 out. So it becomes 8. I have p minus 2mn, and then I have minus n minus m, and then I close it, and then I have 1 minus 4, which is minus 3. But instead of minus 3, if you don't mind, I will write minus 8 plus 5. That's also another way to write minus 3. The reason I did that, I want to factor 8 out, and I want to keep this number positive. So it becomes 8, and then I will have p minus 2mn minus n minus m minus 1, and then I have plus 5. Okay, so this number is an integer because p, m, and n and 1 are all integers, and I have of course some negative signs, so definitely this number is an integer. So let me call that integer capital Q. So this becomes 8q plus 5. Okay, so what I showed using the previous statements and the assumptions that a, b, and c are all odd, I showed that b squared minus 4ac is of this type. It's a multiple of 8 plus 5. And then you know that by division algorithm, for example, if I consider this the set of all integers, z, you know that either numbers are 8q or 8q plus 1 or 8q plus 2, yes, and then up to 8q plus, for example, 8q plus 5, yes. So I'm lazy to write all them down. So the next one is 8q plus 6, and finally 8q plus 7. Okay, so these are the possibilities when you use the division algorithm. If I consider the set of integers, the set of integers are either multiple of q plus 1, multiple of q plus 2, up to multiple of q plus 7, and you know that these partitions have nothing in common. So the intersection between this part and that part is empty, yes? So it means that if a number is of the form 8q, it cannot be any of the other forms. Now you see that b squared minus 4ac is of this form, so it lives here. When it lives here, it cannot live there. So a number of 8q, a number of the form 8q plus 1 cannot take the form of 8q plus 1. Sorry, the number of the form 8q plus 5 cannot take the form of a number of 8q plus 1. So showing that this number is 8q plus 5 means it is not 8q plus 1. So this means that this number b squared minus 4ac cannot be a complete square, and then we are done. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.